Yeah. Good morning to one and all. Today we are going to discuss our next concept here as electric heating wise. In this specific one, just try to understand the thing here. Our subject name here is utilization of electrical energy. That too, we'd like to go for the part of first concept wise heating. That may we call it as electric heating. In the initial days, we come across the thing of conventional heating methods. Let it be we are having some wood material, coal, oil, gas. With the help of these things, we can have some fire there. Then we can use it that particular heat for the household purpose or any other industrial purpose also there. This one is the conventional methods. Coming to the part of, I just want to replace all those things with the help of some electrical power. Then we can produce some sort of heating. Yeah, that type of thing maybe call it as electric heating. We all know that. Let it be, try to choose one medium having some resistance R. When current passes across this particular thing, we can produce some power loss there. P is equal to some I square R. When I would like to multiply with the time, it becomes some energy. That energy may be called it as heat energy. Don't forget the thing here. We can follow only some basic line. Power is equal to work by time. From that, what's that work is nothing but power into time. And I know that power formula here is I square R. And what's this entire thing is nothing but it's a heat energy. That too, we can use that particular heat energy with the help of which thing here? Which type of input I would like to give it here? Electrical supply, that it is current. Yeah, this one is the basic line. Just observe these things here. And what are the different classification of heating methods? Depends upon the temperature wise. If it is a low temperature, I can call it as up to 400 degrees centigrade. If it is a medium, we can have some temperature range of 400 to 1150 degrees centigrade. Beyond 150, 1150 degrees centigrade, maybe call it as high temperature region. Coming to the part of what's that heat transfer can happen with the help of some three modes of operation wise. That may be call it as conduction, convection, radiation. We all know that at let it be we can have some fire like this. We can have some bowl, and if conduction is nothing but just observe this one is a conduction. Heat transfer can be having with the help of one substance to the another substance due to the direct contact. Yeah, inside the bowl we are having some water. That water will boil out directly with the help of some fire means that it is the direct contact wise. That type of thing may be call it as conduction. The molecules will liberate it out. We can have some heat energy there directly. Next option, convection is nothing but the transfer of heat. Let it be, I can have some heat here now. I can use some bowl in between the part. Inside the part of this thing, we can have some water. There is a medium will be there. Initially, this heat will goes to this medium. Then only this medium will transfer that heat to the part of inside the water will boil out. That type of thing may be called as convection. Radiation in the sense we can have some fire rays, all these things will travel, radiation. Energy that is radiated or transmitted in the form of rays, waves or else particles. That type of thing may be called it as radiation. All these three comes under which category? Modes of heat transfer. Next thing, what are the essential requirements of a good heating element? I would like to have some heating element now. That heating element also will follow some requirements there. That will have some high specific resistance there. We can choose some high specific resistance means small length of wire may be required to provide a sufficient amount of heat. That's a crucial point. Melting point is also high in order to withstand some higher temperature wise. Melting point. What's the third option here? It has some low temperature coefficient there. For accurate temperature control, we can have some low temperature coefficient of resistance. These are the requirements of a good heating element. Free from oxidation. Don't neglect this point here. Free from oxidation in the sense the element material should not be oxidized. When we expose to the outer air which has some oxidation there, and it can have some low life there. The lifespan of this particular heating element will be reduced when we have some oxidation wise. That it is free from oxidation is a crucial thing. It has some high mechanical strength, and obviously it's a non-corrosive material. Economical wise, the cost of the material should not be so high. All these are the different requirements of a good heating element. What are the materials we can choose it here is We can have some combination wise. What are the combinations is I can choose some nickel, chromium, and thereafter iron. It's the best combination. Combine all these things here in order to have that reduces the cost wise. I can join this particular nickel, chromium, iron for the proper selection of material for heating element. Depends upon the requirements. These are the requirements here. The first combination is nickel, chromium, 80% nickel, 20% chromium. And the second one is nickel, chromium, iron, 60, 16, 24. This one is the best combination out of all these things. Why means it has some specific resistance is a 110 there, and the working temperature is approximately 950. And in between, this one is also best. But coming to this one, it has some oxidation effect there. That's why I'd like to prefer the part of nickel, chromium, iron. Cost wise also, it's a cheaper. Yeah, don't forget the thing here. Type of heating element here is nickel, chromium, iron. And we have some failure of heating elements is also possible. All these are the different mechanical failure is the first option, oxidation, formation of hot spots, and corrosion. Yeah, remember all these things also you have to keep in mind while choosing that heating element. Mechanical failure, oxidation wise, and we can have some formation of hot spots, corrosion. Yeah, don't neglect all these 4 points while choosing that particular heating element. These are some theory wise. Yeah. Coming to the part of what are the different electric heating methods here is mainly they can categorize the things into three parts here. The first and foremost part here is try to remember passive elements. We can have some resistance, inductance, capacitance. Don't forget the thing resistance, inductance, and capacitance. The first one resistance category here is it's a resistance heating. Next one arc heating. In that resistance also we are having some direct, indirect. Same arc wise, direct, indirect. These two comes under which type of passive element? Resistance. Next one L. L stands for inductance. And the heating here is induction heating. In that also we are having some direct and indirect. And the third category here is capacitance. Capacitance is nothing but so two parallel plates like this now. What's that in between medium? Dielectric medium. That type of heating may be called it as dielectric heating. In our syllabus wise, we are having some resistance, induction heating, and dielectric heating. In capacitance, there is no direct, indirect, only one thing. Whereas remaining all these three parameters will have some classification, direct and indirect. These are the frequency levels. For the resistance, it's a 50 to 60 hertz. Whereas this one is a 5 to 500 kilohertz. This one is a gigahertz capacitance range. Yeah, it's not in our syllabus, but remember these two are comes under the category. For each and every part of this electric heating, classification wise, remember three parts of resistance, inductance, capacitance. And whatever the question, you can pose in the examination point of view, you have to remember the parts of this particular basic principle, Joule's law of heating. Just make sure that you have to write Joule's law of heating. Just only one simple line. Let it be this one is some material wise having some resistance of R. When current passes across this particular having some material resistance of R here is we can have some power for work by time. From that work is equal to power into time. And what's the loss here is I square R is the loss, power loss. And I can increase the temperature wise, current wise, everything means it can liberate it out some heat energy. That heat energy formula here is I square RT. That law of heating is nothing but Joule's law of heating. This one is the main principle we can write in the part of heating there. Electric heating, I can write only one formula, I square RT, Joule's law of heating. Same in a similar fashion, while going for this one is the principle for the part of resistance heating wise. Coming to the part of induction wise also, we can have some principle. I may use some transformer like this. Yeah, when current passes across this particular transformer primary, we can develop some magnetic flux. That magnetic flux will travel all the way and cuts this number of turns like this. It can produce some sort of induced EMF. That one maybe call it as Faraday's laws of electromagnetic induction. Only one thing, it is a coil. When current passes across this coil, we can develop some magnetic flux phi. This flux will cut this number of turns at 2 points and we can develop some induced EMF. But we can produce some I square RT now. That's why I'd like to convert this particular thing with the help of making some short circuit like this. Then this induced EMF will convert the things into current. Yeah, we have to bring that current. What these currents is nothing but these currents are eddy currents. That currents only will produce some sort of heat energy. That's the only thing. Primary side, I can produce some flux here. It can produce some induced EMF. It can turn it to the secondary side also there. It also produce some induced EMF. Induced EMF is nothing but voltage. Voltage is nothing but in between 2 points we can exist. When I can make this particular voltage to current, make it short circuit like this, and it becomes current. Those currents are nothing but eddy currents. These eddy currents only will bring some heat energy. With the help of that heat energy only, we can have some heating effect. That it is I square RT. That's it. This one is the principle I'm used it for the part of which type of heating here? Induction heating. What's up with the question? Just write this one. That's enough. In a similar fashion, try to go for the part of third category wise, capacitance, or else we may call it as dielectric heating. What's the dielectric heating is nothing but we all know that two parallel plates, those are nothing but electrodes. Yeah, I'd like to supply some AC or else DC. When I would like to apply some potential here, it can create some electric field here, positive and negative like this, strong electric field. And unfortunately, positive cycle is, I can apply positive negative electric field here. Same thing, negative cycle I would like to apply. Again, this entire polarities will reverse out like this. There is some orientation of these dipoles will happen now. Due to that particular thing, inside the part, we can have some dielectric medium. That medium is the heating element. I would like to heat this particular element. This one is the line you have to write. Electric dipoles will try to change their orientation according to the part of which thing direction of electric field. Just remember, when I would like to change this particular positive negative cycles like this fastly, these electric field will reverse out like this, and it can create some sort of heat energy. That heat energy will heat this particular dielectric. This one is a heating element. Then we can sort it out that particular heat energy. Some energy will be wasted out now due to the part of which thing interatomic frictions. These atoms will travel from this side to this side now. It creates some interatomic friction. That loss may be called it as dielectric loss. It creates some sort of which thing heat energy. Yeah, these are the things you have to write for the part of resistance, inductance, capacitance. This one is the thing. First one, resistance heating. Make sure that in terms of this technical point of view, whatsoever with material we can heat it out. That material may be called it as one specific name, technically charge. I would like to heat this particular charge with the help of which thing here? Resistance heating. Yeah, that too direct. Remember, direct in the sense the charge element I would like to heat it out directly. Indirect in the sense make it in a bowl like this and heat that one. That may be called it as indirect heating. That's it. Choose some two electrodes like this and give it some supply, electric supply, and it can pass some part of which thing here. Current passes across this one. Inside the part we can have some resistance element, and it can have some which thing here. We can create some sort of Joule's law of heating, I square or T. With the help of this particular Joule's law of heating, I can heat this particular charge. Yeah, we can have some electrodes. These two are electrodes. And we can have some powder is also there. What's this powder? High resistance powder. In order to reduce that short circuits. In order to reduce short circuit, I may deter out some powder like this. Directly I can heat this particular charge. Yeah, that type of heating may be called it as direct resistance heating. Only one thing you have to write here is I square R2. Yeah, in this method, electric current is made to pass through the charge or the substance to be heated. This principle is employed in which type of thing? Electrode boilers. And also we can have some heat treatment of metals, resistance ovens, everything we can heat it out. Yeah, just supply has to be given. And we can have some I square RT here. With the help of that specific one, I can heat this particular charge. This type of heating may be called it as direct resistance heating. In a similar thing, indirect resistance heating now. Only one thing, make it in a chamber like this. I can keep this particular one in a chamber. Same electrical supply. The center surrounding part may be some jacket like this. This one is the heating element inside the part of the chamber. Initially, current passes across this particular one. We can have some I square RT. We can have some heat energy, but initially the outermost part is heated out there. When the heat energy grasps out the outermost part, then this heat energy is used to the part of inside the part of heating element. What's this heating element? Maybe call it as charge. This one can be happen with the help of which thing here? Convection or else radiation. What's these two things? Modes of heat transfer. Whereas in the previous direct, we can use some conduction. This type of thing is used in terms of which thing here? Immersion water heaters. I may use it in water heaters. Yeah. Try to go for the part of arc furnace, direct and indirect. Arc furnace, same thing. We can give it some supply like this. But in this particular thing, we can create some sort of inside the part. This one is the charge we have to heat. There is a gap inside the part of this charge and these electrodes. When current passes across this particular thing here, we can create some sort of arc. This one is arc. Yeah. Then only with the help of this particular arc striking, there is a gap now. Directly contacted to this heating element, it can produce some heat energy. Yeah. When we can use some supply like this, it can create some sort of arc. That arc will directly contact to the part of which thing here? Charge. Yeah, this type of thing is nothing but we can use it in terms of production of steel. Steel production, we can use this arc heating. Indirect in the sense, use some two electrodes like this. Force we can split this particular things, two electrodes. We can create some sort of arc like this. That arc will transfer towards the part of this heating element. Whereas in the previous one, directly that arc is going to the part of charging. Whereas this one, indirectly it can reach towards the part of this one. Transfer of heat. That it is due to the part of which thing? Convection, radiation. Due to the convection and radiation, it can't go directly. Indirectly, it can reach towards the part of charge element. Two electrodes and it can create some arc. Yeah, coming to the part of induction heating, we all know that which type of principle we may use it here? Electromagnetic radiation. Electromagnetic induction. That it is Faraday's laws of electromagnetic induction. This one is the primary side and this one is the secondary side. In this one is a charge. I have to heat it out. Secondary side. I can give it some supply like this. It can produce some part of magnetic flux. That flux will cut this particular thing. We can produce some induced EMF. Same amount of flux will travel towards the part of other side. It can create some sort of induced EMF. But due to the closing of this particular chamber, it can travel as a part of which thing here right now? Current. And it can create some Joule's law of heating I square RT. Then directly this entire charge is heated out there. With the help of which thing here? Induction principle. From one side to the part of other side, it can travel some sort of electromagnetic induction. Then it can create some I square RT and it can heat these particular charges. This type of thing maybe call it as induction heating, that to direct. Yeah, one thing, currents are induced by the electromagnetic action in the charge to be heated. What type of currents here? Can anyone? It's obviously eddy currents. Don't forget, we can use some eddy currents. Which type of principle you can use it? Electromagnetic induction. That's it. Heat treatment of non-ferrous metals like aluminum, copper, zinc, lead, everything we can use it there. Heat treatment. Yeah, this one is one more typical thing, Ajax vac induction furnace. Previously, when I can have some heating element, when I can have some heat of this particular chamber, when I heat this particular charge, I can pour in the other thing, I can use it there. Entire charges will, heating element will pour to the other section. Whereas Ajax box will have some structure maybe like this. When I can heat this particular charge, when I can pour to the part of other thing, some amount of molten charges will be here. That we can't pour entirely like this. At the time, there is a short circuit can be happen. There is current traveling will be there. When I can insert some other charge material, it is easy to have this particular charge material there. It's just a construction structure, construction wise. This company will find out this particular thing. It's an improvement for the part of which thing here, direct core type. to overcome some disadvantage here. What's the disadvantage here means it can't lose the entire heating material. Some amount of heating material is inside. It is creating some sort of current passing like this. Heat energy is simple to create. That's only V structure channel. Yeah. Another thing here is indirect core type. Just same thing, primary winding, secondary winding. And I can have some chamber like this, indirect now. Inside the part, we can have some heating bed. We have to heat this particular circles like this. Same thing, current passes across this particular thing. It can create some magnetic flux. We can develop some induced EMF and we can short out this particular thing. We can have some which type of currents here for the heating of this particular thing? Eddy currents. Those eddy currents will create some heat and it can heat this particular outermost chamber only there initially. Then that heat is transferred towards the part of this particular charges. This one is a detachable. Indirect in the sense there is a chamber. We can heat this particular chamber. Then only the charges will heat out there. There is a chamber there. The chamber is nothing but charge heating bed. This one is detachable. Which type of principle? Same, induction principle. We can use it with the help of which thing? Convection and radiation. Indirect in the sense convection and radiation. In this method, eddy currents are induced in the heating element by which principle? Electromagnetic action. Yeah, the heat developed is transferred to the body due to the part of which thing here? Radiation or convection. This one is the thing. We can use it in terms of which thing here? Heat treatment of metals. Yeah, coreless. Just we can have some core material like this now. Inside the part of this one only we can have this one. Whereas in this specific one, coreless in the sense, I don't use this particular one. Directly we can create some sort of tube type structure. Inside the part only, we can travel some currents and it can heat that particular charges. This one is a charge. There is no core. Yeah, it is a simple thing, but the thing you can remember here is absence of core material. Heat developed in the charge is due to the part of which thing, same eddy currents, and we can heat that particular charge material there. Only construction wise is different. You have to write all the basic principles. Yeah, coming to the part of this dielectric heating, I can use some two electrodes like this, same AC supply, use some supply here, positive cycle, positive negative like this, negative cycle again positive, negative. There is interchange of these particular things now. This electric field will change like this. Due to the part of this particular a change of orientation will be happen now, this electric field, there is some heat energy will be liberated out with the help of some dielectric laws. Due to the part of which thing, interatomic friction. It can create some heat energy due to the changing of this positive, negative like this. These fields will travel like this and I have to heat this particular thing. This one is a charge here. I have to heat this particular charge. Due to the part of which thing here, interatomic friction wise, we can have some dielectric laws and it can appear as a part of which thing? Heat. That heat will heat this particular electric material, dielectric material. We can use it in the part of which thing here, preheating of plastic, baking foundry cores. We can use it as different applications wise. Yeah. Next thing. This one is a classification wise differences between induction and dielectric. This one is for the part of L and this one is for the part of C. You all know that we can use which type of principle here? Electromagnetic induction. Whereas this one here is we can have some alternating electric field, changing of poles. Then we can create some sort of heat energy. Principle of operation wise. Faraday's laws of electromagnetic induction, whereas this one is electrostatic induction. Frequency of AC supply, it's approximately 100 kilohertz to 500 kilohertz. Whereas in this specific one, we can have some megahertz here, static, electrostatic. Cause of heating here is eddy currents induced in the object due to the part of which thing electromagnetic induction. Whereas this one, friction, interatomic friction. Area of heat production, surface of the body. Don't forget the thing. This one will have surface of the body. Whereas this one, inside the material. Two parallel plates now, inside the part. We can have this one. Types here is direct and indirect. Whereas this one, no further classification wise. This one only direct and indirect. Materials to be used here as any metals there, whereas this one we can use it wood, plastic. Why means dielectric medium is the wood or plastic. Cost of heating element is relatively less, whereas this one is somewhat expensive there, dielectric. Heat distribution of the body is non-uniform, whereas this one, it can create some uniform distribution. Applications point of view, we can use it surface hardening, shouldering, bracing, annealing here, whereas this one, drying of wood, food processing, cooking, baking, and gums or gluing, etc. like this, we can use it. Remember, this one is for the part of which thing? Inductance, and this one is for the part of capacitance. Coming to the part of advantages of this particular electric heating, it's obviously economical, cost-wise, cleanliness, no pollution-wise, it's a pollution-free. Easy to control everything here. Uniform distribution in terms of which thing here? Capacitance. Efficiency is also higher there. Temperature also is higher. Safety-wise and protection-wise, everything is possible in terms of which thing here? Electric heating advantages. In terms of applications point of view, domestic or commercial point of view, we can have some heaters, kettles, dryers, ovens, toasters, everything. We can use it in a household purpose-wise. Yeah, thank you for watching here. Just make sure that try to recollect all those basic points of three things here: resistance, inductance, capacitance. That's it. Thank you. If you like my video, please subscribe to my channel.